Okay, so today we'll talk about the network types. You will be dealing with networks as infrastructure technician type of a person, or a project coordinator on this level, or a support person on that has to do with that. So whenever you're going to install things, sometimes you're going to design small networks, and sometimes you're going to be servicing them, and sometimes you're going to be installing things that somebody else has designed things. So it is important that you know some sort of at least basic terminology, and what do you eat that thing with? All right. So here's a little funny picture that I got from the internet. Haha, funny. Okay, let's go. Let's start with some of the definitions. What is a computer network? A computer network is a group of computer systems and other computing hardware devices, which is pretty much anything that connects to Ethernet and internet as well could be. So a group of computer systems and other computing hardware devices that are linked together through communication channels. Remember that our channel signal chain of our communications. Communication channels will be the links, all right? And what will be the links? Copper or fiber or air, right? So, okay, so that are linked, group of computer systems that are linked to facilitate communication and resource sharing among a wide range of users, all right? There was a period there, okay. Networks are commonly categorized based on their characteristics, okay? Here's a mouthful. We just spent a few seconds on that. Let's go for the next page. Network types. This is what we're going to be talking about. These are the most basic network type classification stuff. All right. We're going to be talking about LAN, which stands for local area network. WAN, wide area network. WLAN, which is wireless local area network. It's a wireless LAN. Right? MAN for metropolitan area network, SAN for storage, and of course we can't forget about the VPN, which is becoming more and more popular on the consumer level. It was quite popular for a number of years on the commercial level. Now it's becoming more and more widely used. All right. Now, here is a little picture that I took from one of my installations. Remember, I'm asking you to take pictures when we're going to do the labs. I'll be asking you to take pictures of your work. Get used to that idea because you're going to be taking a lot of pictures at your work. It's going to be part of your job. So, so now when after so many years that I've worked in the business, I got a lot of pictures that I can pretty much share. I just can't share any of the sensitive information, but if I can take a picture like that and show it to you, that's just fine. All right, so what do we have here right away? This is a gateway from one of the stores that I had to replace a faulty one, right? So sometimes you're going to be replacing equipment that exists. So what do we have here as lights? We have OK light. Well, that's a very important light. If if the OK light is not on, then things are not okay, I guess, right? Wow. All right. Now another light that came on is WAN, WAN, which means that the system has found and locked itself onto the WAN, right? Which is WAN, wide area network. What's a wide area network? That basically is the internet, which means if this light is on, that means this piece of equipment is communicating with the internet, right? Now we have the LAN here, right? We have LAN ports, LAN 0, 1, 2, and 3, so 4 ports. That means there are a couple of pieces of equipment, something and something. Two things are connected to the LAN ports, which are the Ethernet ports, which are the most basic computer jacks on the other side of this equipment here. And then when we have pressed the on button and this thing took its sweet time to boot up, and initialize and all that. So this light came on, and then bang, this light came on, and then there's a bit of a disco lights going on because this thing is, playing with whatever subroutines that it has to do. And finally, whoa, yeah, deep breath, deep sigh of relief. VPN came on. VPN is virtual private network. All the stores, anything that is chainable as corporation. So there could be a corporation of whatever fast food restaurant, or corporation of production plant. Whatever the production that has many, the company could have many production plants all over the world, and all of them are logged on first on the internet, and then they have purchased a piece of internet that they have for their own. It's a piece of a bandwidth. It's a space on internet that is private to just them. And through that virtual private network, all the transactions that are done on cash registers, all the phone calls that are done, anything that has to do with the communication within that corporation happens through the VPN, and it's a secure type of a network. Nobody from outside can penetrate that. Well, that's the idea, and the whole thing works as one huge network. It almost is bringing up. It's almost like combining all the facilities that exist throughout the world. It could be on different continents, so it just works almost like a local area network, right? All right, so local area network. See, we had the list of that, and we're going to take them one by one a little bit. Oh, okay, come on. There we go. All right, LAN stands for local area network. All right. What does it do? It connects a group of computers in close proximity within the same facility, right? Or a building or a group thereof. It's almost like a legal language. So basically, if there's a building, there's a company, it will have a computer network designated for it. And that's going to be called a local area network. Local area network can be extended to pretend that other things work as part of it, which we just talked about, the VPN. But let's just take one thing at a time. All right, the purpose of the LAN local is to share resources and services such as files, printers, applications, email, or internet access, and the list can go on. Now, this is the basic type of a scenario of a LAN. What do we have? We have dry end-to-end links, which we will practice how to connect on a smaller scale. And then all you have to do at work is going to be, to repeat the same thing on, just going to have longer cables, right? We're going to have two jacks present right in front of you on a desktop, on a desk, or I don't want to say desktop because desktop could be a desktop computer. No, on a countertop. And you're going to see one end, you're going to see the other end of it. But in reality, as you go, the cable is going to be longer, and the desktop location jack could be somewhere on, above the countertop or underneath the countertop, and the other end could be in another room. Same thing, it's just longer cable. So what does it? What do we see here? Let's analyze that picture just a little bit. All right. We have a bunch of wires running to the same point. See, these are the dry links. There is a wall plate with a jack on it, and it has a cable that connects to another jack on something that's called a patch panel. And for the sake of installation, that's all is being done as far as installing the infrastructure for the network. Later on, the IT people will come in and plug in the equipment. On one side, it could be a PC or a projector, overhead projector, or it could be wireless access point. It could be any kind of a device that talks to Ethernet, and you want to, any kind of a network cabal equipment. Right? On the other side, that other jack will be connected to some piece of equipment here, which usually will be something that's called a switch. Switch, in the simplest term, you can say that it's the Ethernet or LAN signal traffic controller. So the way that we run those wires, we call them home run. Right? It's also called horizontal run. And we'll talk about that. Home run is basically everything home runs. Everything go bang, 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 right? So it goes right to the one common location. There's a jack, and there's the same jack on the other side, except this one is mounted on a wall plate, and this one is mounted on some sort of a frame that we decided to call a patch panel. Right? And then from this patch panel, one to one, those things are being patched with a patch cables or patch cords on one-to-one basis to each to designated port of a switch, so the traffic can be controlled by the switch, and things are being processed further by other pieces of equipment. Right. So that's the pretty much scenario of a LAN. Why do we call it a horizontal run? Horizontal run is well, basically all the home runs that go to the same, I would say, LAN room. Okay. Now, things would be too simple, right? Let's complicate things just a little tiny bit. One network can consist of multiple LANs working together. Right? What do we mean by that? Example, the same LAN can be divided into, well, logistically, into different departments such as accounting, production plant, management offices, and so on, just so the signal traffic doesn't get too jammed. Right? If there's a big company, if there's a lot of information being exchanged between the machines or computers, just from the accounting department, let's keep that thing on a separate switch, on a separate sort of like a, I don't want to use the word subnet because that could mean something else as far as setting up networks. But it would be something like that. It would be sub network, right, or part of the bigger network. The huge network can consist of few smaller networks, just so the traffic gets routed between the machines that usually communicate with each other, so the traffic is easier. Right? These different departments can be on 3 different LANs within the same company. Okay, all right. Confused yet? Don't worry, we'll confuse you soon enough. Come on. I want to be able to switch slides. All right. So we continue with that. LAN. As we remember, we connect a group of computers in close proximity within the same facility, a building, or a group of buildings. All right, so here comes the next slide. I just took a snapshot from Google Maps. I just wanted to have a couple of buildings that are in close proximity. I don't know what these buildings are. I don't know where these buildings are. I don't know whose. I just needed to have 2 buildings close together so we can pretend that this is one huge company for the purpose of this lesson. And this thing here was supposed to be a tree or something like that. All right, so here's one building and here's another building. Now, remember, let's say this is the same company, one big company, and they want to have a LAN, local area network, but there is a little tiny bit of a problem because, well, they are 2 separate buildings. So how do we do that? Do we have 2 different LANs? Well, not necessarily. We could still have that on one LAN. That could be 2 buildings, could be 3 buildings, could be 5 buildings. Whatnot, right? You're going to be installing some of the linkages soon enough once you get jobs. All right, let's just choose that, for example, one main building. Let's say this is the main building, all right? And it will have a LAN room somewhere around, maybe in this corner here. Okay? Now, just by looking at this analogy here, there will be a bunch of computer jacks or Ethernet jacks from which the cables home run to that LAN room. So This LAN room could be here, and this could be a bunch of jacks, smart devices, all over the place. That home run to this spot right here. Well, what about the computers over here? Well, we gotta connect them somehow. So what do? Do we just extend a bunch of wires and go to the same spot here, do a home run? Well, no, we're not going to do that. Right? We can do two different things. Let me see. Control L, I think it's for the full screen. There we go. So I want to introduce you to, slowly but surely, I'm going to throw things in, some terminology that you will be using a lot within the business. So here is the first. Well, you already got introduced to the LAN and the Ethernet and wired, and what's a home run. Now I'm going to introduce you to something that's called a media converter. Right? Media converter sometimes is being called, also known as media player, but for the most part, it's a media converter. Remember when we talked a couple of weeks ago when we talked about transducers? And what are transducers? What are transducers? A transducer is a device that converts one form of energy to another. Now, here is something similar. Well, that could be like a microphone, right? Or a loudspeaker. But here's a similar idea. Here is a media converter, and media converter transfers one form of signal to another. All right, what can we do to join these buildings so they work on the same LAN? All right, there's the next slide. I thought it would be creative. These are the two buildings. Look at this. Here's that line, red line right here. When I press the button, boom, the red line appears. What you could have is, instead of running all the wires from all the computers from the other building to that LAN room, you could have one or two links, which would be just maybe 4 strands of a fiber optic cable. And those 4 strands, or maybe sometimes even 2 strands. Why do we need 2 strands of fiber optic? Well, one communicates one way, and the other strand or fiber optic line, or we call them strain, it would communicate the other one. So considering from here would be transmit and receive, or from here would be transmit and receive, okay? So now if you want to have more data flowing through, you could just introduce another link, which would be 2 more strands of fiber. So you will have 2 transmits and 2 receives. You can transmit more data. Whichever way, what do we need is something that is called a media converter on one side and a media converter on the other side. Now, the copper cables can only transmit so much data. They are quite efficient for what they do, but they can only transmit so much data. Yes, you can get ones that transmit more than others, but then things get expensive, and well, sometimes it's more practical to have a different approach, like such as this, using a media converter and transferring the signal over a couple of fiber optic links, and one fiber optic links can transmit a lot more than one copper link. Right? It's all about money, right? Some companies, yes, they do. They implement fiber to the desktop. It's another terminology, fiber to desktop. So all the desktop computers are running on a fiber connection. Some companies do that, right? But still, copper is going strong, and Cat5e is still going strong. However, slowly but surely, it's going to be replaced by Cat6. However, depending on the length, Cat6 works as Cat6 only up to, I think it's 180 feet, and some sources will give you 160 feet. Then it works as Cat5e, right? If you want to get full 300 feet, because the most you can communicate with copper cabling is 300 feet. Well, it's actually 328, but you never installed full 328 feet because you still have to have some sort of room for the patch cords and connecting links, right? So they adapt the distance as well, right? So 300 feet end to end. If you want to get Cat6 capabilities, then you should get the Cat6A, which is way more expensive. All right, so let's go back to the media converter. This media converter here would convert the electronic signals or electric signal, such as Ethernet, to a blinking light, and it blinks very fast, right? Like blink, blink, blink. I can't even say it fast enough, right? All right. So we need something to convert the signal from one to another, and it's called a media converter. And this media converter will have different inputs and outputs, right? So you're going to have a transmit connected to another media converter here. So you're going to have two media converters. One to connect the copper from this side with fiber, optical fiber, or fiber optic. And the other one do the same thing with all the copper cabling signals, with electronic signal, electric signals, Ethernet signal, excuse me, and communicate with the blinking light that's just going to travel through the fiber optics. So media converter here, and copper wiring here, and copper wiring here. So here would be the main LAN room, and sometimes we're going to call it a MDF, which stands for main distribution frame. There's only one MDF because it's called main distribution frame. You can only have one main distribution frame in the form of a LAN room, right? Local area network room, right? Main distribution frame, same thing. And over here, you would have also a LAN room, but it would be called IDF, which stands for intermediate distribution frame, which is kind of like a sub LAN room, right? So this would be the main backbone, where the main backbone lives. And the backbone is, well, it's a home run. Everything comes to here, and everything branches out from here. And this would be the main distribution frame, the MDF, will have something that's called a demarcation point. A demarcation point is a point of entry. So that's where all the outside connections will be terminated here. So the internet is being brought from outside, it will go to the demarcation point. If the phone line is being brought from outside, you'll go to the demarcation point. Right? Now you can have main demarc point or demarcation point, and you can have a bunch of secondary demarcation points. Like for example, if let's say telephony, in telephones, you're gonna have so many, like, well, let's say that Bell Canada, that's we have in our case here, would decide to bring 100 lines here, and they know that there's a link between these two rooms, so all 100 telephone lines will be brought to here, and then some of the groups of lines could be extended. Maybe 25 or 50 telephone lines are going to be brought to the secondary demarcation point. So it's just going to be some of the 50 of the lines are going to be distributed by the eaten up by this building, and then maybe there's going to be other, well, let's say if this is a shopping mall or something, there will be a shoe store here, there would be a hair salon, there will be a restaurant, there will be what else, and you're going to have a secondary demarcation point. So shoe store needs 2 telephone lines, okay, a hair salon needs 5 telephone lines, the restaurant needs 3, or so on. So from the second demarcation point, the lines would be just distributed from there, and this would be just a dry link between those, just an extension of that, right? So you have learned something that's called the media converter, LAN room, distribution frame, which is a LAN room, main distribution frame, and intermediate distribution frame. So you're going to see MDF and you're going to see IDF, or bunch of IDFs. You're going to see MDF and you're going to see maybe some closets, communication closets that are going to be labeled IDF A, IDF B, IDF C. If you ever go to one of the local hardware stores, Home Depot is a great example of that. Look up on the walls, maybe 20 feet high, 15 feet high. You're going to see some boxes that are refrigerator size mounted on the walls, and you're going to see huge labeling on that. IDFA, IDFC. These are the intermediate distribution frames, which contain patch panels, which contain switches. We'll talk about that in greater detail a little bit later on. Right? All right, so media converter here, there's not one kind of media converter. Media converter can convert different signals into different signals. So there's not just one universal media converter. You would have to order one that converts Ethernet to, well, optical fiber type of a signal. Right? All right. There's another way that you can solve this problem or this challenge or this issue. Instead of an underground fiber optic line, or sometimes overhead, but usually underground, you could have a wireless link. The only thing is, with the wireless link, you need to have a line of sight. That antenna has to see this antenna, and they have to be pointing at each other. So if there will be a third building somewhere here with the wireless antenna, well, there will be another antenna here pointing at that one, and that one pointing at this one. So it'll be two here, one pointing at this, the other one pointing at the other one, if there was another one, right? So then also you would need a media converter, but it would be a different type of a media converter, which would convert Ethernet signal, combined Ethernet signal, and it will be modulated onto a electromagnetic waves type of a communication, right? Into a radio signal that also goes back and forth. And yes, you will have a media converter here associated with transmitter and receiver and whatnot. It will be connected to antenna, and then you will have another system just like that in this building. So now you know what a media converter is. Sometimes they're called media players, and they are more associated with, like, for example, if you go to any fast food restaurant and you see those so-called menu boards on top of the, at the back wall. So when you're standing buying a cup of coffee, for example, you're looking at those bunch of monitors that are displaying the products and the prices and so on. And you can see that those menu boards, they're called menu boards, they could be synchronized. So if there's a ping pong ball traveling from one monitor to the last monitor, it just goes through all the monitors in between. So they, quite often they're, well, always they are synchronized, and there's subroutines are being played through them. Those also have something that's called media converters or media players. Right? Sometimes they're called media players. Same thing, media converter, media player. Those media players or converters are converting the Ethernet signal because they're also connected to the Ethernet port of a patch. Well, they're connected to a patch panel on the other side, and that patch panel port is plugged in or patched to another switch, just like any other smart device, just like a PC, just like a VoIP telephone or a wireless access point or anything. It's plugged into the same thing. It's plugged into the Ethernet, right? So the signal from the Ethernet is converted onto whatever the TV or the monitor can understand. And they are also synchronized on the network level, and everything is, everybody happy, right? Yeah, there we go. So another media converter or media player. All right, let's keep moving on. All right, structure of LAN. How is it structured? LAN cable structure example. Not all networks are up to the highest standards. Some service calls will look like this. Well, can we see the same elements here? What do we see? We see a bunch of something that looks like a makeshift patch panel, and there are wires coming out of it. 1, 2, 3, 4. 4 wires coming out of that one. 1, 2, 3, 4. 4 wires coming out of that one. The other end of these wires goes to wherever the desktop locations are, PCs or whatnot. Right? Over here, we have the patch cables connecting us to a switch. All right, so everything works. Now, we're probably going to have something like a gateway, and the gateway could be connected to a modem. All right. Can you see the similarity here? It's just another version of that. Here would be the jacks, the quadruple jacks on the wall, connected to a switch, and those wires are going to wherever they go. Come on. There we go. Here is. All right. Now, sometimes you're going to have to use your laptop in order to tap in with, and usually it would be Ethernet cable. It's just like the computer cable into the gateway. And sometimes you're going to need to tap into the modem. Now, don't worry, don't get intimidated by what I'm saying right now. Nobody is going to ask you to know everything about everything. Yes, if you want to upgrade yourself and get into the IT type of thing, then more power to you, right? But quite often, as a installation or service tech, you will be able to you'll be required to know how to connect. Well, find the Ethernet port on this equipment, find the Ethernet port on your laptop that you have with you, and connect them with the wire. And sometimes you're going to have to log in to that through a web browser, or sometimes you're going to have to log into it through a command prompt on your laptop. Right? Same thing with here. Now, what do you do once you connect? Well, whoever sends you is going to be the company who designed the system and who services that system. They just need you to be on site. So you'll be on the phone with a level 2 support technician who will know all the passwords, who will know all the structure of whatever this is, how this thing needs to be programmed. And sometimes they're going to ask you to press this on the keyboard and type that and press enter, whatever, right? So that will be the gateway. Service calls replacing gateways are quite popular, or installing new ones. Modem, also write down the terminology. Quite often you're going to be asked to program the modem into a bridge mode. The modem can be bridged or unbridged. When you order just a regular internet service from whatever company you do, now sometimes you go to pick the modem up, sometimes this thing is being sent to you by mail. Whichever way you get it, it's pretty much ready to plug and pray. Right? Yes, I said plug and pray. That's the new version of plug and play. All right, excuse me. So that's how it is done on the consumer level for the most part. Now, when it comes to a commercial level, all the setup of the restrictions, permissions, and the way things need to run, what needs to be connected to what, all the stuff that is associated with how the network is supposed to run, all that information is going to be in that gateway. Because they don't know whether you're going to be here in London, whether you're going to be somewhere in the East Coast, West Coast, wherever you're going to be, you might end up with having a different modem, different internet connection. So that is going to be common to all the, let's say, store that sells shoes, and it's nationwide kind of a store that has many stores. So all those are going to be programmed the same way. What you will have to do is set the modem to a bridge mode. What's a modem? Modem is a combination of two words, modulation and demodulation. So cut those two words together and you get modulation, demodulation device, which is modem, all right? On one side, on this, when it comes from outside, the signal is in an analog form and it modulates it into a digital signal, Ethernet, in the form of Ethernet, right? And it makes the communication back and forth possible. So sometimes you're going to have to put that modem in the bridge mode, which means none of the signal logistics are going to be directed by the modem. All you need the modem is a kind of a interface between the inside and the outside world. So it's supposed to pass the internet through in its raw form and just convert analog to digital signal right to the gateway. So this is just going to be a connecting device to whatever company. And they just want that thing to pass through the signal, not to do anything with it, not to have any permissions and restrictions or whatnot. It's just passing through. So that's called bridging. When you bridge modem to any of the Ethernet ports that are on the modem that is bridged, you can't plug in just a PC and expect to work. If the modem is unbridged, then yes, all the Ethernet ports are, you can just plug in a computer and it's going to work. If the modem is bridged, it just passes the Ethernet signal and they're going to have ports on the, well, that thing is going to connect to the switch. Sometimes the gateway is going to have a few ports by itself. You can connect the PC right there, or you can connect the PC to the switch. So that's how it works. Now, you see, I say not all networks are up to the highest standards. Here's the thing that that I'm going to try to make sure that you understand. This is somebody's business. They do what they do. They sell shoes, they change, tires, whatever. It's a hair salon, it's a bird, it's a plane, whatnot. You're going to see in your ways, you're going to see things like this. Some of them are going to be full of dust and grease, and sometimes they're going to be nice and with designated separate rooms. This client doesn't have to know that. That's their business. They own this piece of business, they run it. Treat them with utmost respect. You're going to see things that are organized better, not so good, not so well. You treat every customer as if that person was $1 million type of a customer. That's how you make money, and that's how you are going to have a professional demeanor about you. And plus, well, if I said this in this way, if I give you that reasoning, you never know, that client could have 100 more of those service calls like that for you, and it could be to your benefit to behave properly. Or I could just say, you never know, this client might know some other client who has a huge facility and is going to give you a lot of work. You could have that kind of, but that would be somewhat primitive reasoning. Do something because, just do it because it's the right thing to do. Never mind, you never know thing. And you never know thing will come by itself. Don't worry about it. Just be professional. Right? All right. Now, some of the service calls were going to look like this. Not a lot. However, you might be employed in a company that services that. Now, don't worry. Also, don't be intimidated. This is this, except there's more of those stuck together. Right? That's it. What I'm going to point you to here, well, a few things. What they write here? Consider the power required to service the equipment. Look, there's a lot of power going through. In fact, when all this stuff is running, you need an air condition to run. Couple of those two verticals sections, it's almost like a house barbecue running full blast, and it doesn't stop. Look how many of those are. This IT equipment, it produces a lot of heat. So not only you have to provide extremely huge amount of power to power this whole thing up, but you also have to deal with the heat that it produces. You have to have a lot of power spent on the air conditioning unit to be able to cool things down. Excuse me. And if you don't, this thing would not last. If the equipment, if the air conditioning unit fails, this whole thing fails within about an hour. It would not last an hour. That's how much heat it produces. That's one thing. The other thing is, look how many, all these stuff, these are not wireless. These are all connected somewhere. There has to be a lot of wires going through here. Yes, we have some sort of raceway. Here's those orange ones. That usually means these are fiber optic lines here going into that protective sleeves, going somewhere else. And there's some more fiber going there. But there's also a lot of copper. But look, here's a raceway. Here's a cable tray on top, and it's pretty much almost empty. Where are all the wires? Where are all the wires? It's got to be somewhere. Also, what I want you to be familiar with and know something that exists, it's something that's called a raised floor. And that's what it looks like. Raised floor. They have one like that here. Expensive floor, but big companies can afford it. And just so you can make yourself look smart, whenever there's a raised floor, you don't just pick those tiles with your fingernails. These are heavy and massive. They have to, you walk on them. A lot of people walk on them. So the frame has to be nice and sturdy. Whenever you walk into that and you see that, and you're going to know that you're walking on the raised floor, you're going to ask where there's always going to be those suction cups to lift those tiles. Okay? Whoever is there, manages the facility, they will know where these are. They have to be there. Right? And look, it's a beautiful way of running wires. Nice and clean way. Run the wires, you have access to them at all times. Once you install those wires, bang, put those ceiling tiles, floor tiles right back in there. And you're dealing with something that's called a raised floor. All right, wide area network. We talked about that already. WAN joins an unlimited number of smaller networks in a way that the devices of different networks can communicate with each other, which basically is the internet, wide area network. All right. So now, here's an example of an old modem or a so-called box that's being sent to you if you order internet. Let's analyze some of that. All right. Okay. We have something that's called DSL. And that looks like a phone jack. Well, it is phone jack because DSL is a digital subscribers line. It's an internet signal superimposed onto a phone line. So this will be a DSL port. So if the signal, the internet, is provided to you in a DSL form, that's where you connect. You connect that to a phone jack. Or sometimes you connect that thing to a discriminatory device, like a filter that filters out, separates the signal into just phone and just Ethernet, right? Or DSL. We'll talk about that more a little bit further down the road as well. A lot of things. We're starting up and we're going to expand on. Now, what do we have here? LAN 1, LAN 2, LAN 3, and LAN 4. You can connect, if this is not bridged, you can connect the PC straight into it. Or if the internet, in this particular device here, if the internet is provided to you through some other modem, and that modem signal needs to be connected into this box here. Here is a LAN. You can't see it, but trust me, it says WAN here. So LAN 1 or WAN. So if you have another modem before that, providing the signal, processing the signal, and this you're going to use just like a router, or maybe some sort of a miniature switch, then that signal from the modem is going to be plugged into the WAN here, wide area network. So this works as both, right? And then you have reset and whatever power connection here. So, normal stuff. All right. Now, I'm going to finish on wireless. So we are both on the same page with this both groups. Wireless local area network, wireless. As the word wireless suggests, this is a type of LAN that uses wireless network protocols to establish communication between devices. Wireless, right? Is it possible to have a complete, almost 100% wireless? Why do I say almost? Here is a wireless access point. Those are all around our school. Try noticing them. This is a WAP, wireless access point. Sometimes they're called APs, just access point. Different people call it different way. That's a wireless access point. This thing is wireless, but it's not 100% wireless because that is plugged in to the network, and the wireless communication happens between this device and your cell phones, your laptops, and whatnot. All right, so can you spot the wireless access point mounted around the school? Try to solve it pretty much in every classroom. There's one, at least one, and in the hallways every so often you're going to see those. All right, you can see them also in the conference rooms and whatnot. One more thing: metropolitan area network, a network spanning over a physical area larger than LAN, but smaller than WAN, such as a city. City is on its own network, and it's called metropolitan area network. All the traffic lights, all the city cameras, all those speed traps and whatnot, they connect to the metropolitan area network wirelessly through wires, whichever way they connect to MAN. Right? Storage area network or system area network. You know what? This is where we're going to stop because we're running out of time here. It's 12:54, and you probably need to go to other classes, and so do I. So that's where we're going to continue that in when next time we see each other, which is probably going to be in person. Yeah, next class. All right. Okay. Okay, so I can see there's I'm confused. Who has lab today at 8 p.m.? I'm in section 2. I'm going to right now. I'm going to make a list. I'm going to post it in announcements, and these are going to be the names for that. Thank you for reminding me. All right. If you don't see it, scream. But you're going to see that list in about, I don't know, 10 minutes or so. Cool. All right. Good thing I noticed that. Yeah. Anything else here? I was like, yeah. All right. Make sure you bring your safety glasses. And that's it for today. And I'll see you when I see you. And I'll see the rest of you guys and gals when I see you, the rest of you gals and guys. Bye.